Hey y'all. So we're now going to begin exploring chemical kinetics. And kinetics is really just a fancy name for the rates of chemical reactions. So we're exploring the rates of reaction. So rates is kinetics. Okay? So when we think about rates, in the context of, let's say, speed limits, what we're thinking about is how quickly you can go from point A to point B, right? So we have this displacement of distance, so we'll say a change in position, and we take this divided by how much time it takes, so divided by the change in time. So this is a rate. Well, in chemistry, we think about rate in the same way, except in thinking about it in the context of position, we now think about the rate of a reaction in terms of changing concentration of our reactants or our products. So we're thinking about it in terms of changing concentration of, let's say, our products divided by a change in time. So the rate of the reaction is defined by how quickly the concentration of products change. A fast reaction will have a large change in products in a small change in time. And a slow reaction will have a slow change in products in a long time. Okay, and we can just kind of in general think about this as an xy coordinate where on the y-axis we have the concentration of our products and on the x-axis we have our time. Right, so we can think about this as a rise over a run. So the slope of this line then is going to be the rate. Okay, so anytime we're plotting the concentration of products or the concentration of reactants versus time, the slope of the line is the rate of the reaction at that time. Okay, but what is really important to note here is that the rate of the reaction will change as a reaction proceeds, right? So hopefully, right, so if we think about this, we have reactants becoming products. So as reactants get consumed, the reaction will naturally slow down because there's less of an opportunity for reactants to interact with each other. So what we really end up observing is a kinetics curve where we see the slope of the line changing. Okay, and at any point, right, so at the very beginning here, the slope of the line is the rate at the very beginning of the reaction. As the reaction proceeds, we see the slope of this line changing. So the rate at this time is smaller than the rate at the beginning. And as we proceed even further, the slope is shallower, meaning that at this point in time, the rate is even slower. So the rate changes as the concentration of reactants change or as time proceeds. Okay? So what this means is that thinking about the rate of a reaction just in terms of changing concentration of products over time isn't completely accurate. There's more involved here because the rate of the reaction has to be sensitive to the concentration of the reactants that are available. Okay, and this idea leads us into what we know as a rate law. So we're going to very generically introduce a rate law right now, and then in a subsequent lecture we're going to explore that a little bit more. So the idea here is the rate of a chemical reaction is equal to some constant. We call this our rate constant. Okay, so this is a lowercase k, times the concentration of something, the concentration of your reactants to some power. Don't focus too much on this right now, but because we're going to explore it a lot more in the future. But what I want to point out to you is that the rate of the reaction, right, the slope of the line here, the slope of the line at any point, is dependent on this rate constant and also on the concentration of the reactants. So as the concentration of your reactants decrease, the rate will also decrease. Okay, and that is perfectly shown in this plot here. Right? So we see as time progresses, we know that reactants are being consumed, and as reactants are being consumed, these concentrations decrease, and as the concentrations of reactants decrease, then the rate must correspondingly decrease. Okay, so what we're going to be looking at over the next several units, next several lectures, is we're going to explore this idea of what the rate constant is, what it means, where it comes from, what all goes into understanding the rate constant. And then we're going to explore this rate law in a lot more detail. We'll figure out how to determine rate laws for chemical reactions. And we'll also see interesting ways of using them so that the rate law becomes useful to determine how the concentrations are changing for a chemical reaction as time proceeds.